Hi everyone, my name is Srujana Challa and I'm going to talk to you about the integration or acceleration of IPsec in virtio-net device. The purpose of this presentation is to explore how IPsec can be integrated in virtio-net device. Before we proceed to the main topic, I would like to provide a brief introduction to the IPsec protocol. IPsec or Internet Protocol Security is a suite of protocols designed to secure IP communications by authenticating and encrypting each IP packet in a communication session. The key features of IPsec are data confidentiality, keeps data private, data integrity, ensures data has not been tampered, authentication, verifies the identity of communicating parties, replay protection, prevents attackers from intercepting and replaying the packets. IPsec has two key protocols. ESP provides confidentiality, integrity, and authentication. AH protocol provides data integrity and authentication. IPsec operates in two modes, tunnel and transport. Let's quickly see the example of IPsec ESP protocol in transport mode and tunnel mode. Transport mode, only the data portion of the IP packet is encrypted and authenticated. The original IP headers remain intact. In tunnel mode, the entire original packet is encrypted and encapsulated in a new IP packet within a new IP header. The integration of IPsec within virtio-net device includes these key updates. It introduces new capabilities, resource objects, and flow filter actions, as well as updates to the virtio-net header structure to accelerate IPsec processing in virtio-net device. We will cover these details in the next slides. Let's look at how an IP packet undergoes outbound IPsec processing using host-based cryptographic operations. First, let's establish our components. The host is the entity responsible for initiating the packet processing. The virtio-net device is the network interface device that will transmit the processed packet. Both the host and the virtio-net device are connected via a PCIe slot. When a host wants to send a packet securely, it performs IPsec processing, which includes SA lookup to find the appropriate SA for the packet. The SA contains the necessary parameters for IPsec processing, such as encryption and authentication algorithms. Then pre-IPsec processing to add additional header to the packet as required by the IPsec protocol. Next, cryptographic processing and post-IPsec processing. The fully processed IPsec packet is then passed to the virtio-net device via the PCIe. When IPsec processing is accelerated within the virtio-net device, the host's role in handling IPsec processing changes significantly. Instead of performing the entire IPsec processing workflow, the host now only needs to perform the SA lookup. This involves identifying the appropriate SA for the packet, which contains the necessary parameters for IPsec processing. Once the SA lookup is complete, the host provides the plain packet to the virtio-net device. The virtio-net device then takes over the IPsec processing responsibilities. This includes encrypting the packet, adding any required headers, and generating any integrity check value to ensure the packet's authenticity and integrity. After completing the IPsec processing, the virtio-net device securely transmits the packet over the network. Similarly, for inbound traffic using host-based cryptography, the host is responsible for the entire IPsec processing workflow. The whatever net device receives the encrypted or IPsec packet from the network and forward it directly to the host via the PCIe slot without any modifications. The host then performs the entire IPsec processing including SA lookup, decryption, authentication, and final packet preparation. In the accelerated case, the whatever net device takes on the responsibility of IPsec processing. Here is how it works. The whatever net device receives the encrypted IPsec packet from the network. Then the device performs the entire IPsec processing, including decryption and authentication. This involves SA lookup, decrypting the packet payload, and verifying the integrity check value. After processing, the whatever net device passes the plain packet to the host via the PCIe slot. Host then can proceed directly with L3 processing. Now, let's talk about the advantages of integrating IPsec with virtio-net. As we see in the above slides, moving the IPsec operations to the device reduces the host CPU usage and improves overall performance. It enhances security by performing encryption and decryption operations inline. By moving more operations to the device, it becomes more secure as the path cannot be tampered with by the host software. It benefits the devices that already support inline IPsec processing, such as those from Marvell. It can be integrated well with existing kernel and user space virtio net drivers. Establishes a foundation for adding more inline processing offloads in the future, such as MACsec, PSP, and DTLS. Next, we will explore the design and implementation details of integrating IPsec into the virtio net device. virtio-net IPsec uses the basic facilities of capability and resource objects, which were recently introduced in the virtio specification. The capabilities and resource objects are managed through an admin word queue. virtio-net IPsec utilizes these generic virtio admin commands and introduces new IPsec specific IDs or types within them. Integrating IPsec into virtio-net requires two capabilities: virtio-net IPsec resource cap and virtio-net IPsec SA cap. The device and the driver indicate IPsec SA resource limit using the capability virtio-net IPsec resource capability. The virtio-net IPsec SA capability defines the IPsec protocol features the device supports. The mode specifies the IPsec operating mode, which can be ESP transport, ESP tunnel, AH transport, or AH tunnel. virtio-net IPsec reuses cipher algorithm, HMAC algorithm, and AAD algorithm definitions from the virtio crypto device. The device can define the IPsec protocol features for each mode. Integrating IPsec into virtio-net requires the introduction of two resource objects. The IPsec SA resource object contains necessary parameters for packet encryption and decryption, including IPsec mode. Mode we have discussed in the previous slide. Direction specifies inbound or outbound. Object ID is resource object identifier of the SA. SPI, IPsec packet identifier. Options. Drivers can ask the device to apply these options for the packet Options include extended sequence number support, UDP encapsulation, DSCP copy support, DF support, TTL decrement support. Tunnel header parameters and data specific to cipher authentication. Both the driver and the device can use this SA object for managing the IPsec SAS. Flow filter in virtio is used to direct network packets to specific receive queue based on certain rule. Virtio net device can apply flow filter rules to match packets and take specific actions, such as directing packets to a particular receive queue or dropping them. To integrate IPsec, two new flow filter actions are introduced. virtio-net flow filter action IPsec. With this action, IPsec processing will be applied on the packet and then put on a virtio-net RQ. And then virtio-net action IPsec recirculate. With this action, IPsec processing will be applied on the packet first. Subsequently, the packet will go through flow filter rules again for the second time and try to match other flow filter rules based on decrypted packet content. This is useful when application or user wants to match packets based on decrypted packet content rather than encrypted packet content. One of most important use case of our customer is single IPsec tunnel, a fat tunnel, where there is only one IPsec tunnel and application wants to distribute traffic based on inner packet payload for scaling across cores. This outlines the high-level flow of the virtio-net IPsec operation in the control path. If the driver requires IPsec processing, it first sends a capget admin command with the type virtio-net IPsec resource cap to determine the limits on the number of SAs. Subsequently, the driver sets the limits it will use. The device uses these limits for further processing. The same approach applies to SA capabilities. Next, the driver uses the virtio-net resource object IPsec outbound SA or inbound SA admin command to create the SA by setting a unique object ID and all the parameters in the SA resource object structure. At this stage, device saves this SA and adds it to a lookup table for future data processing. virtio-net IPsec processing introduces additional changes to the virtio-net header structure. If driver needs IPsec processing for an outbound packet, it sets the virtio-net header of security flag in the header and passes it to the device. The device then performs the IPsec processing on the packet and sends it out. Similarly, if an inbound packet undergoes IPsec processing, device sets the same flag to inform the driver that the packet has gone through the IPsec processing. If IPsec processing fails, the device sets virtio-net header of security error flag. The resource ID is the SA object ID used for IPsec processing for this packet. Now let's talk about the virtio-net IPsec outbound data path flow. In the outbound IPsec flow, if the driver needs IPsec processing for the packet, it sets virtio-net header of security flag in virtio-net header flags, sets resource ID to already created object ID, sets resource type to virtio-net resource object IPsec outbound SA. Then the driver passes the packet to the device. Device performs SA lookup using resource ID, adds ESP or AH header, adds ESP trailer if it in ESP mode, encryption and authentication processing, and adds ICB, adds IP header if tunnel mode, and sends the packet out. In inbound flow, when the device receives IPsec packet, it does SA lookup, decryption and authentication processing using the SA parameters, removes tunnel header if in tunnel mode, removes ESP or AH header, removes the ESP trailer, sets the flag bit whatever net header of security or security error in the whatever net header flags, and assigns the resource ID to the SA resource object ID that the packet has utilized during IPsec processing. Then it passes the packet to the driver. Driver checks flags for whatever net header of security or error. If it will drop the packet if it finds error. Currently, RFC patches for this proposal are in the discussion on the whatever command mailing list. The reference link for the patches can be found here. Our plan is to implement support for inline IPsec in whatever NetDriver for Marvel DPU devices using the Marvel vhost VDPA driver, which is already upstreamed, and introduce more IPsec options such as checksum computation or verification and tunnel header verification.
Hi. Thanks. This is a really interesting work. I got a lot of questions to come up with. First is, why do you need SPI there? And if you have it, is the device reconfigurable at runtime? When you rekey it, wouldn't the SPI change?
SPI is for is there to identify the SA in the inbound path.
When you rekey the SA, you will have a new SPI. How does the virtio device get that?
When we recreate it,
rekey using the IPsec protocol. When you have a timeout or you rekey an ESP SA using the IPsec v2 protocol, then SPI change. So can you reconfigure the virtio device when the SPI changes?
Yeah, currently we didn't look at that path, rekeying and all. Now it's a RFC proposal. We will add incremental changes for that.
Rekeying is important for IPsec.
Yeah, we will add
and
in the future.
Next question is in IPsec v2 you get some of the configuration parameters through IPsec protocol, like for example internal IP addresses, DNS, and there are a few more variables you can get. How do you pass that to the virtio?
We will use this. We are planning to use admin commands only to pass any information from the driver to the device.
It's not from the driver, it is from the IPsec protocol.
No, I think just to add, right? So basically, IPsec is outside the scope of the virtio net device. So basically, IPsec processing would be still done in the host, and as a part of rekeying, it would create a. I mean, it would need to destroy the SA and create a new SA, right, in the device. So device is like stateless with respect to that. I mean, it just maintains the state of an SA, and like it maintains soft expiry and hard expiry and things like that. But the renegotiation or rekeying part needs to be triggered from the host, right? So then the device doesn't need to process the IPsec packets.
No, I mean, when you negotiate IPsec protocol, you can also get address from the other side. It's called internal address 4 and internal address 6 and the DNS. So those come via the IPsec protocol, And usually, typically, you configure that on the ESP side.
Yeah. So we can create, so the only thing that, okay, those are the result. Okay, you mean the result of, so from what we understand, basically the result of IKE negotiation would be SPY, right? And algorithm and then master key, or which is used as a key, right? And yeah, so, and then some other parameters, right? Like tunnel header information and things like that. So
No, that's not what
you're
I'm
talking
talking about. No, I'm not talking. I'm
yeah.
talking about RFC 7296, section 3.15.1.
Okay. Yeah, I think we didn't look more detail from my point of view. So our initial plan was like, I think even the current inline crypto support that the kernel has, right? Kernel framework provide. I mean, the kernel Netdev framework provides, and where all the net drivers are registering. So there also we thought like IKE is outside the scope of the device as such. It's a negotiation that would be done by the kernel stack, and then the state of the session would needs to be passed on to the device. But yeah, maybe we can look at it further and get back.
Anybody else? Otherwise, I can go more questions.
Yeah. Thanks for this interesting presentation. The part I don't understand is what are the changes compared to the XDO dev policy, XDO dev state, which are already available with the XFIM framework, that we can already use with some of the physical NICs, because virtio will just be one more net device. So I'm confused.
Yeah, I can answer that. I think basically, so kernel already provides a framework to offload IPsec to net device as inline crypto, right? So there won't be any changes in the framework point. I mean, the kernel Netdev framework as such. We would use the existing inline IPsec framework in the kernel, and then the virtio and net device would expose inline crypto features there. So I hope.
So to make it short, your proposal is to add the crypto XDO to virtio. Am I correct?
Yes, yes. I mean, crypto offload capabilities to virtio Netdev.
Okay, thank you.
There's also, Joel, do you want to ask a question? If you can, put on your video. I don't think I've ever met you. I know who you are, but I've never met you.
Let's see. Camera is not actually working at the moment, but yes, I'll put it on hopefully tomorrow if I have a question. So the question I have is, are there any like actual performance benchmarks or results, any charts you could share? I know you mentioned that it drastically reduced the amount of load on the CPU. I was just wondering like what the amount of load you had and you were testing with when you were doing this work.
We have not yet implemented this. Right now it's in the proposed, I mean, RFC. We have submitted RFC patches for whatever spec. So we will implement and
yeah, just I mean, we can probably share the other data that we have. Like we so as a Marvel one of the Marvels, many of the Marvels Option SOCs, right, support both inline IPsec and look-aside crypto offloads, right? So the virtio net device spec that we are proposing is nothing but inline, right? Where packet comes through the wire and gets processed through IPsec on the device and then reaches the kernel in a decrypted form, as opposed to a encrypted packet reaching the kernel, then kernel sends that packet back to a crypto accelerator to get it decrypted, right, and then get back. So we have like the numbers that we see are like around, I mean, we see a 50% improvement in our, not in a virtio netdev case because that we are still implementing, but in our benchmarks where we compare look-aside versus inline. So we think we would get similar improvements there, even with virtio netdev, right? Well, important feature actually with this case is that like so like the fat tunnel case that Srujana was mentioning, right? So where let's say you have a single IPsec tunnel, and if it is processed inline, then the decrypted flows can be RSSed to different cores, right? So that there it would scale across cores, right? Versus you get that all the IPsec packets of that single tunnel to a single core on kernel in the kernel stack, and then they get decrypted, right? So there you get it. I mean, you get limited performance. So that is another important thing.
So, another thing I don't understand. So you say you do this implementation for Octeon, but in that case, why not adding these features on Octeon net device first before doing that for the virtios? Because I think there could be many benefits to get such offloads for the host Linux side.
Okay, so Octeon net device, you mean the SDP? Are you referring to the Octeon EP driver that is currently there in the kernel, or?
Yes, the Octeon kernel drivers. So if we have such XFM XDO on the Octeon net device, we could offload the crypto IPsec to the Octeons.
Yeah, I think that also is in progress. We are, I think they are already, so not the SDP side. So we already have Octeon. So we have RView drivers in kernel, if you see under Marvel. So there we are already having patches in progress to add support for inline IPsec inbound and outbound, right? So those patches are, I believe, already in review. So that's done by a different team, but I think we can share the series if it's interesting. So those patches are already in review. And apart from that, though it's a different domain, the DPDK, we already have all the drivers upstream. But yeah, kernel netdev support for inline IPsec, that's already in progress. So there is already a series in review.
So which means that could we have two levels of crypto offloads? One from the host net device.
Yes.
Then we forward to the virtio. So what does it mean if in the guest I configure a packet offload to the virtio, and then out of that virtio, the host side will offload it to the physical net device? How do you manage the two layers?
No, I didn't get your question. So as an Octeon, right, we support two kinds of devices here, right? One is Octeon acting as a standalone SoC, right? So it's there is no virtio net device as such. We have native Octeon drivers there, right? The virtio net device support we are talking about is when Octeon acts as an endpoint card and connected to a x86 host, right?
Okay.
So virtio netdev is used there. If Octeon is running as a standalone device, or a root complex, right? So there we don't have virtio. We have a native driver support, and the inline IPsec I was mentioning is already being added there.
So which means that let's assume we are not talking just about your CPU, your Marvel CPU. We are on x86 with PCI LAN cards that can do IPsec offload. We run VMs, and in the VMs we run IPsec. So what's the story? I mean, I'm confused. So the VMs offloads over virtio towards the host side, and the host side itself has some offloads towards whatever NICs. So both has their respective XFRM packet offload. So what's the story in that case?
Yeah, so basically, when we're talking about host, right? So the current Octeon devices support 64 VFs, right? So we expose them as 64 whatever VDPA devices on the host. And when you assign each of them to a guest, right, the guest, so in this case, so since you have moved the virtio-net device to guest, the offloads control is fully in the guest, right? Like any other checksum offload or any LSO, right? Similar to that, the IPsec, if you move the whole virtio-net device or whatever VDPA device to guest, then the control of essay creation or sending traffic to be encrypted and all is in the control of the guest, right? So it's just like any other offload, right? Even checksum offload, if you are saying checksum or LSO, when you assign a virtio-net device to a guest, everything is in control of guest, right? We are talking about real virtio-net device here, right?
Okay, thanks, Vincent. Christian, you had a question online? Christian? And I think we'll make that the last question. Sorry, it's break time. Can we put him? He's on Zoom. That will be the last one, and then we'll call it a break time. You found him? Christian, CHRISTIAN. Helps. So if you want to ask a question online, please you can click on raise your hands. That way we know. Okay, Christian, you can unmute yourself and talk, I think. Are you there, Christian? Okay, maybe I'll ask his question for him. Can you see the question, or should I ask? Seems like everything IKey related will have to be passed to the host. Is that correct? If you're running an IKey daemon.
Yes, I think all the IKE packets would be passed through to the host like any other Netdev.
Okay, thank you.